Hello, I'm Kelly McConvey, a PhD student at the Faculty of Information at the University of Toronto. I will present our work on algorithms in higher education. This work was completed with Dr. Shion Guha and Dr. Anastasia Kuzminykh. The use of algorithms for decision-making in higher education is steadily growing, promising cost savings to institutions and personalized service for students, but also raising ethical challenges around surveillance, fairness, and interpretation of data. To address the lack of systematic understanding of how these algorithms are currently designed, we reviewed an extensive corpus of papers proposing algorithms for decision-making in higher education. In this project, we set out to answer two key questions. What are the current trends in the design of algorithms in higher education? And how are human-centered algorithm design approaches used in the development of those algorithms? First, we'll review our data collection, coding, and analysis methods. Using combinations of the keywords higher education, algorithm, predictive analytics, and machine learning, we searched the ACM digital library, identifying 9,038 papers. We removed 4,620 duplicates and screened 4,418 titles. From there, 413 abstracts were screened using our inclusion criteria, and 236 full papers were screened. Our final corpus included 62 papers for synthesis. The included papers were peer-reviewed, published work containing an algorithmic approach with a technical discussion of the data used. They used student data within higher education and were published between 2010 and 2022. The papers we reviewed for their statistical approaches or machine learning models, target outcome variables, and specific data input types. Coding categories were developed from the results. In order to analyze the papers in the context of human-centered algorithm design, we also deductively coded each paper as demonstrating the dimensions of theoretical design, participatory design, and/or speculative design. We adopted Baumer's human-centered algorithmic design framework to consider how the design of algorithms aligned with or were led by educational theory, how stakeholders were meaningfully included in the data selection, algorithm design, model evaluation, or implementation processes, how the model was evaluated using stakeholder feedback, and finally, how the researchers envisioned their proposed algorithms being used in real-world higher education institutions and scenarios. Next, we'll talk about the results of our analysis. The proposed models increasingly relied on individual student data, such as GPAs, enrollment pathways, and learning management system, or LMS activity, as input features. Use of protected classes like age, race, gender, disability status has grown significantly. Results indicate a trend away from rule-based systems towards neural networks and deep learning methods. This potentially leads to less explainable and less interpretable results. Results show a growing trend towards models developed to predict student success, including grades and attrition. These models are generally built to support institutional retention efforts. Our review also considered the design of the study through the lens of Baumer's human-centered algorithmic design framework to identify which papers employ theoretical, participatory, or speculative dimensions in their design. No papers, to our knowledge, include all three dimensions, and only one paper included more than one element of the framework. All feature categories, except institutional and student survey, were accounted for in papers using HCAD strategies. Interestingly, while 3 papers using participatory design included participant surveys in their design methodology, they did not include surveys as feature sets. Only 1 paper used student survey data in its feature set in the design of a student services chatbot. The HCAD papers generally targeted the more common outcomes of grade prediction and retention, though 2 papers were focused on pathway advising. All of the HCAD papers employed machine learning techniques. Next, we'll discuss the challenges and opportunities identified in our research with the goal of moving towards human-centeredness in algorithmic decision-making. 3 major needs emerged from the trends identified by our review: the need to establish valid and theory-informed ground truths, the need to consider interventions within the algorithm design process, and the need for governance as algorithms move from identifying and informing to decision-making. We found a growing trend toward the use of learning management system data as input features. Student interaction with their web-based learning platform was used as a proxy for their engagement in the course, with an underlying assumption that LMS activity like clicks on videos, frequency of logins, or views of course content is correlated with student interest and participation in the material. Yet in none of the papers was this assumption questioned, or was educational theory presented to support it. LMS interaction as a proxy for engagement and an indicator of academic success is then accepted as a ground truth within the algorithms. LMS activity, though, can take many forms, and there was no discussion within the papers as to the predictive power of specific types of activities. The viewing of a video may not have equal engagement value as participation in a forum discussion, or infrequent but substantial logins may or may not be as effective as frequent brief ones. Additionally, activity can be impacted by many factors, including technological factors such as interface design and privacy support. And the combination of the LMS itself, the course design, and the course type produce different student experiences and influence student behaviors. The ground truth of these models is that students with less LMS activity are less likely to succeed, the output of which will trigger a student-level intervention and not a review of the LMS, course design, or user experience. Beyond incorporating educational theory in the design of algorithms, computational scientists should allow for more collaboration with education subject matter experts and social scientists to analyze the importance of these LMS interactions critically. More research is needed to understand the relationship between LMS activity and engagement. Additionally, researchers must consider how the importance of the individual features of their algorithms aligns not just with target variables, but also with the greater goals and outcome of the algorithm. Before 2018, research focused primarily on designing algorithms to predict student grades and retention. The motivation behind this research is to reduce attrition through the early detection of students who are identified as likely to fail, allowing institutions to provide these students with timely and focused interventions. Interventions vary from automated email notifications, supplementary readings and assignments, recurring meetings with advisors, and counseling services. Few of these papers, however, consider what interventions exist, the efficacy of the interventions, or the institution's legal and ethical obligations to provide interventions once at-risk students have been identified. Additionally, intervention efficacy is difficult to measure. We also did not find any literature demonstrating that these models have been used effectively within higher education institutions. The algorithms seem to be designed within data science silos, with little consideration for their role within the institution or as part of the greater student experience. An algorithm designed to increase retention cannot only be evaluated by its performance in predicting which students may not succeed. In other words, researchers should consider the relationship between the specific predictors used in making the prediction and the intervention proposed to then correct the prediction. Even more concerning, however, is the move from retention and grade prediction toward pathway advising and admissions. Algorithms designed for course selection, program admission, and pathway advising have the potential for a more direct and limiting impact on students. Algorithms in higher education are moving beyond the ability to simply provide greater insight to institutions through the identification of at-risk students, but to actually make the decisions for them. As we expect to see this trend continue and the use of algorithms for decision-making expand beyond its current scope, our results suggest the need for more governance within higher education institutions. Our review indicates that it's certainly technologically possible to leave these student decisions in the hands of algorithms, but whether it is desirable for algorithms to shape students' academic careers without the oversight of a human in the loop remains a legal, ethical, and pedagogical question. We encourage you to read the full paper and look forward to any questions or comments. Thank you.